Okay, perfect. So as I was saying, I'm here to present our paper, Explain Ethical Planning Using ASP. Okay, so we place ourselves in the intersection between two very interesting domains, namely planning and ethics. So our fundamental question would be, how can we apply ideas from the field of normative ethics to make agents behave in a way that we can characterize it as ethically correct? So our ideas is to formalize and be able to plan in such a way that we can take into account all these human notions of what is ethically correct or not. And in particular, normative ethics is the subfield of ethics that focuses on having many different theories in which they characterize by different points of view what is ethically correct or not. And then, well, planning models define systems of states and actions in which successive actions must be taken to arrive at a certain goal. And in the field of planning, we're going to focus on classical planning problems. So that is that the states are always able to be fully observed and the actions are deterministic. So yes, and as all ethical work, we are going to start with a dilemma to be able to exemplify later on our notions. So our dilemma goes like this. So we have an autonomous vehicle that is tasked to get its passengers as fast as possible from their house to a hospital because there has been some kind of urgency. So we can either get through a highway or a side road, which is much slower. And to take the highway, the vehicle has to pass through a toll and present its ID. So if it's present its own ID A, it will have to pay a fine as it's not allowed this particular ID to go through a highway. But if the vehicle presents another ID B, so if it lies about its identity, then no fine will be paid. So the planning framework that we are going to use for classical planning here is the strips-like domain. So it consists of a set of fluents, which are the variables that characterize each state. So in this case, where the vehicle is at, whether the toll barrier is open, whether we have a fine, whether we lied, where we took the highway. Then S0 represents the initial state, which is an assignment from the fluents to their domains. Then the goal condition would be a mapping from some set of the fluents in V to their domain. So it would be what we call a partial state as well. And then O is a finite set of actions or operators of the form of a pair, pre and F, that denote the preconditions and the effects of the action. So the precondition is something that must be satisfied in a particular state in order to execute an action. And the effects is the set of fluents that change their value as a result of the action. So basically, given a state and an action, the successor state is defined if, as I said before, the preconditions are included in the previous state. And if it is indeed defined for every fluent, it is changed to the new value if the fluent was present in the effects of the action, and otherwise it remains the same as in the previous state. So in this strips-like domain, a plan is a sequence of actions that goes from an initial state to another state that should include S star, which would be the goal condition. So this goal condition should be in the successor of applying all the actions in the plan from state S0, which is the initial state. So for example, here at the right, we have a graph, and we can see the different ways that are defined by our domain of getting through from the house to the hospital. So we have 3 ways. Of course, this is a simplification of our graph. There are other possibilities, but these are the ones that we are going to focus here. So we can see that we can either go through a side route, or we can go through the highway, either by presenting ID A and ID B. So this is the full strips-like representation. And then in normative ethics, our main question, as we kind of stated before, would be what kind of ethics can be applied to planning and decision making, and how? So normative ethics studies the possibility of actions. So what is right to do in a certain situation? There are many branches. In here, we are going to focus on two, which are the most research about, which are consequentialists and deontological. So consequentialists tells you that you can only consider action consequences and then compare the consequences of action to determine which outcome is the best, which is something that is rather discussed in the literature because well, basically, if you only take into account a consequentialist view, it can have not so good consequences in situations of extreme trade-offs. And then there is deontological, which is a normative ethics theory that considers what you can do and you cannot by setting up a set of rules which are strict and capture moral obligations and prohibitions. So basically, in the literature, we can see that consequentialist theories are captured in regards to decision-making and planning with a utility function that takes each action or each state, in this case, a state, I mean a mistake here in the slide. So take out state and give you a utility of, so for example, if we take the highway, this has a positive utility, but if we had a fine, then it has a very negative utility. And then the ontological tells you when things are permissible or not. So for example, in our problem before, we can say that the utility of each fluent is this and that, and we can prohibit certain behaviors such as lying, which is something that is typically discussed in the ontological literature, because lying is always believed to be disallowed. So basically, in planning, we implemented it in ASP, which I will get in a couple of minutes, by just a utility function on the fluents under assignment, and then the ontological by a set of norms, which are of a form of a pair, which are either a prohibition or an obligation, and an enforcement condition, which tell you which fluent assignments should hold and should not hold up at a particular state. So basically, this is how all the utilities will end up being modeled as. So the utilities should be added all throughout until the final state, which achieves a goal. And then the idea is to compare all the possible plans in order to determine which one is the most ethically correct with respect to utilities and norms or other kinds of normative ethics theories. So the implementation that we did consisted on taking answer set programming, because it allows us to test ideas using logic programming. And also by using logic programming, it enables the planning system to be explainable, because there's much work on explainable logic programming systems, as we've seen in the previous talks today. So there are many ASP planners that are very efficient, and in particular, we are interested in the planning ASP literature because, for example, we can see that strips domain encoded in PDL, which is the main language for encoding planning programs, can be directly translated into ASP using, for example, PLASP. So basically, we can take an ASP domain, and then what we did was develop an ASP planner that takes into account the actions along with the utilities or possible prohibitions that a domain can have ethically, and then we apply the Klingo ASP solver in order to run the rules and find the answer sets. Okay, so this is, for example, an excerpt from the hospital problem. We can see that using ASP, it is very, very direct, the way in which we can implement the domain in strips like fashion using ASP. And then, for example, we can model the utility by just using a utility function, which afterwards the planner takes. So this is a fragment of the planner. Basically, the planner, using ASP, we were able to, for example, use this aggregation function that ASP provides in order to compare the different utilities of each plan, and then define the prerequisites of what is permitted or what is forbidden with respect to each possible normative ethics theory that we define. And then the idea is to apply it in order to select actions with the predicate occurs, which we see at the end, which basically selects which action it will take at each timestamp. So timestamps are used in order to model which actions succeed each other. And then in the last line, we force only one action to be selected in each possible timestamp. So yes, so basically, in order to provide explanations, which is our main goal, we can do so by using an ASP approach for normative ethics, because as we have seen in previous literature, there are many works that enable to provide justifications for particular literals. In our case, we are interested into providing a justification of why certain actions were chosen ethically and why other actions were not chosen on ethical terms. So basically what the literature provides, amongst many other things, is ways of constructing justification trees for particular fluents with respect to a given answer set and a program, such as the one that we showed before. And with this, we can provide a justification on ethical terms of why each action was forbidden or not, or why each action was chosen. Okay, so that's that.